So in this video I want to talk to you very briefly about Boolean logic as it applies to designing digital circuits. This idea really came about thanks to this man, Claude Shannon, back in the 1930s and 40s. He is actually the founder, considered the founder of information theory, which is a precursor, of course, to computer science as we know it. What Claude Shannon did was he took Boolean algebra, which had already existed for many years by the time he came around, and he applied it to his electrical engineering background, his digital circuits background. In fact, he even took it a step farther. He proved that Boolean algebra can construct any logical or numerical relationship. And so what that means is it allows us to use Boolean algebra as a tool to talk about digital circuits. So if we want to build a circuit, for example, we can actually boil that circuit down to a Boolean algebra expression or a Boolean algebra equation. In fact, since we're on that particular topic, now is a good time to cover some terms. So an expression, a Boolean algebra expression, has no equal sign. It's simply a series of inputs to a particular circuit, for example. So you might see ands, ors, and nots and other operators, but the variables involved are always going to be inputs if it's an expression, and there will not be an equal sign. An equation, on the other hand, will include an equal sign, and so that represents inputs and outputs, which is very useful when we're talking about circuits. If we want our circuit to have a desired behavior, it's going to have inputs and outputs, more than likely. So an equation defines both inputs and outputs, and it has an equal sign. A function, on the other hand, describes a relationship between the inputs and outputs. And so functions can be represented in many different ways. One of those ways is actually equations. So I can represent a function as an equation. Another way that we've already seen a little bit of, and we're going to see a lot more of in the future, is a table, a truth table specifically. A truth table defines a function between inputs and outputs. And of course, another way that we can define functions is as a physical circuit itself. A circuit, a physical circuit, represents a Boolean algebra function between its inputs and outputs. So functions are going to be increasingly important as we proceed, not just with Boolean algebra, but also with building circuits in this particular class. In the next video, we're going to take a deeper look at building circuits and drawing circuits so that we can prepare ourselves to have a more thorough conversation about Boolean algebra and designing circuits using VHDL.